Hi everyone, it's my turn this time. Uh, Thanks for joining us. And Sean, when you're ready, please let us know the question.
All right. So the question is, you are given a array of
Mm-hmm.
integers, both positive and negative.
Okay. Mm-hmm.
Find the contiguous sequence with the largest sum and return the sum.
So the largest contiguous sequence. Wait, sorry. So the
Yes,
contig.
the sequence with the largest sum. So I'll give you an example.
Okay.
It would you
Sorry.
have 2,
Yeah.
-8,
Mm-hmm.
3,
Yep.
-2,
Mm-hmm.
4,
Yeah.
and -10.
Okay.
And your output should be 5, which is 3, -2, 4.
3, -2, 4. Okay. And these, wait, you said continuous or
Contiguous. I think they
contiguous?
mean the same thing.
So the definition is they have to be next to each other, I guess. That's a simple
Yep.
way of understanding, right?
Yes.
So can these numbers be repeated? So could I have something like say 2 here as well?
Yes.
Okay. Um, okay, and I have to find. Okay, so I guess let's see if I have anything else to. Okay, so the array. How long is the array?
Um.
Can I assume it's at least length 1?
Yep.
Okay, so that means I don't have to. Oops. That means I don't have to deal with when I'm given an empty array.
Mm-hmm.
And can I also assume that all input is valid input, so no strings or something like that?
Right.
Okay. Um, so a brute force way to do this would be to start at the first element, and then step through by summing these numbers, and summing these numbers, and summing these numbers.
Mm-hmm.
Oh, am I? So you can see all my entire
Yep.
screen.
I can see. I can
Okay.
see your
Yeah.
picture.
Okay. So that would take uh, on squared because I would be looking at each combination. So I would do this, and then I would start at 8, -8, I mean, and do this, and so forth.
Mm-hmm.
Uh, and I'm sure there is,
What would the runtime be for?
that would be on squared, and I think I want a more efficient way to do that.
Okay.
So, uh, so, hmm. Could I could I optimize my on squared solution? I'm wondering. So,
Yes. There's a much faster way. There is a linear way to calculate.
um, maybe instead of adding, I should look at subtracting. So if ah, so let's say I start with I start with um, I start with the entire array summed up. So it would be this, and
Mm-hmm.
I don't think it would work because I was thinking of removing one element at a time,
Okay.
but then when I remove it, it could be smaller. Let's say here, if I remove 2 from the end, it would be smaller, and I wouldn't it wouldn't mean anything to me.
Right.
So if it was on time, that means I would be looking at each of these elements. And can I use additional space for this?
The optimal solution does not.
Okay.
But what would you do if you were to use additional space? You don't require additional space.
Right.
So I can give you a hint. So the example I gave you are alternating positive and negative numbers. Think about the relationship of these positive alter numbers traversing through your array.
Are the numbers always alternating, or it's?
It is not always
Okay.
alternating, but it's helpful to think of it from that perspective. So start with an alternating example, which is this one.
Okay. So let's see. The sum of this is the sum of this is -6. The sum of this is -5. The sum of this is 1,
Mhm.
2, -6, and -8. What's the pattern here?
So let's walk through like a example. Say if you start at the 2, right? So you've had sum of -6. What happens when you go on to the third member in that list?
So if I so maybe so if I sum -6 and 3, it would be -3, and then if I sum this together would be -5. If I sum those numbers, I would have -1.
So is 2 a good starting point for you?
So it's not because so I need to find a good starting point, and to do that, I think. So
assuming you start at 2, right? What's the biggest sum? Contiguous sum.
Yes, I shouldn't have erased it, right?
No, yeah, that's fine.
So I'm gonna look at all these things, and then look at all these sums and pick the largest one. So it would be 2, and then Um, okay. So the fact that you said it could be done in ON time without any additional storage means that um, well, maybe I might go through the entire list multiple times, but it wouldn't be a function of how long it is. So
Mhm.
I'm guessing I would first have to find a starting point, and then maybe go through the list once to find a starting point, and then after that, uh, at the starting point, I would have to do something. Maybe sum up its neighbors, which in the worst case scenario would be also ON time. So
Mhm. Let's go back to that example
Mhm.
when you summed up all the sequences that
okay,
started with
yeah,
2.
yeah. Okay, so that would be so this would be you can answer that if you want. So -6 plus 3 is -3 plus -2 is -5 plus 4 is -1, -11, -9.
Yep. So what's the biggest sequence or biggest sum here?
So the least negative, I'm assuming you're asking. So the least negative number is -1. I noticed that 5, the largest number, the largest contiguous sum was 5, and that's actually these numbers.
Yep.
And I noticed that I seem to be ending at here both times. So I don't know if that's just a coincidence or if there's actually a pattern. So
So yeah. So for the 2, your largest sum is actually 2, just 2 by itself, right? Instead of
right,
-1.
right, like
Yeah.
that. Okay.
Yep.
So it's not actually. Maybe.
So when do you want to throw out
when I want to throw out
your 2, because it's not a good starting point?
Would it make a difference if I started summing from the right?
It will not make a difference. So think about the relationship between a number and the next number.
Mm-hmm. Number and the next.
So 2 and -8, that's -6.
Yeah.
Already.
Uh-huh.
You already have a negative number.
Mm-hmm.
That doesn't bode well for you going into 3. Could you use that logic to decide what the best place to start is?
So it would be. So I guess I should start with a positive number and then see if well, I could do it at all the positive numbers. I could start at 2 and then look at the next 2, I could start at 3 and look at the next 3. I could start at 4 and look at the next 3. So okay, so if I pick, let's say if I picked a positive number, 2, the only reason for me to include the next one, which is a negative number, is if the third number is large enough to make it worth adding. So I look at -8 and see if it's small, or if its magnitude is smaller than 3. So if basically I would be looking at this number, 3, and I would see if it's greater than -8. Right? You get what I'm saying? I'm looking to see if, sorry.
So you're saying if the third number can offset the negative sums of the previous numbers, then you want to keep it.
Yeah.
Do you want to keep it?
Do I want? Okay, so here, let's say if I had just three numbers in my list.
Yep. What is the biggest contiguous sum here?
It's 3, because
right.
So I would look at each number, and so I still can't do it in one time. I would have to look at the first number, and then if the next number is negative, then I also want to look at the third one to see if it's. So basically, I want to see. So I have 2 by itself, and if the next one is a negative, then if the next one's positive, then I definitely want to add that. If it's negative, then I want to see the next one as well to see if it's worth adding. So in this case, the difference between these is actually, the sum of these is actually -5, so it's not worth adding. If it was, say, if it was like this instead, the sum of these is 1, and it makes it worth adding. So, okay, I guess.
Is that worth adding, that bottom example? The biggest sum is 5 here, instead of 2, -1, 5.
Right, so
think of, instead of worth adding, think of what scenario would it be worth discarding for your starting point in the beginning.
If this number so if, let's say, okay, we want to see when it's worth discarding, right? So
yep.
In this case, it's still not worth discarding.
Yeah, make the middle like a little bit bigger.
Oh wait, it is, because this is. You mean the middle bigger as in like have a longer example, right? So let's go back to our. Let's not.
Yep. This works.
Okay, so I know this is worth discarding because the sum of these is -1, and the sum of this number by itself is just okay. So I guess when I'm at 5, I can look over, and if I see 2, and I want it, and 2 is less than 5, so that means I don't have to use that way. So maybe I need to first find the largest number.
Mm-hmm.
And okay, I feel like I'm not getting something.
Right, so I like the example that you're using, the 5, -2, 3.
Yeah.
For your other example, what you want is an example that drops the 5, right? So let's do like 5, -6.
But then?
And then 7, or something like that.
Okay, so...
Yeah.
Okay, because in this case, well, this is -1, but this... So, first, if it was just 3 numbers, I would compare the second one to the first one. So here, in this case, 7 is greater than 5, I would just... Would I have to do multiple comparisons?
No. Well, so you know 5, -6, 5 and -6.
That's -1.
You would do a -1, right?
So it's not worth keeping. So I would just...
Why is that?
Because if I... Because it just means I'm adding -1 to my sum.
Yeah.
So I guess I would look at each pair. Oh. So I would start from the left. I would look at each pair of numbers to see whether they're worth keeping. So in this case, okay, so let's go back to our previous example. 2, -8, 3, -2, 4, -10, 2. Okay, so I would look at the first 2 elements, and since their sum is -6, I know that it's not worth keeping.
Mm-hmm.
So I'm just gonna look here. Actually, so I'm gonna skip the look at the next positive number. And 3 and -2, that is 1. That's a positive number, so I know it's worth keeping. And so,
okay. So
I'm going to look at the next positive number, or the next number, 4. And, well, I know this is 5 now, so keep that in mind. I'll look at the next pair. That is -8, so it's not worth keeping. But so here I sort of did something that wasn't very well defined. So once I found a positive pair, I didn't discard it.
Okay.
I guess. So I guess the okay. I guess I'm gonna generalize it to. If it was all positive numbers, I would just keep adding, right, until and I would just add the entire array. But the thing with negative numbers is when I see one, I have to do something differently.
Yeah.
So in this case, I would start at 2. The next number is a negative number, so I look at my current sum of 2 and the next number, which is -8, and see whether I want to add this number. And adding it doesn't help because I get -6. So, so in that case, I don't add that number, but I still save my largest sum as 2, right? So
okay.
Let me. Okay, so I have 2 variables. One is largest, I've seen, which is 2, and then the current sum, which changes. So now I've discarded it. So the current sum is 0 again. And then I look at 3. I see 3, and the largest is definitely 3, and the current sum is also 3. Now I keep going forwards, keep stepping forwards, until I find the next negative number, which is -2. And then I check the current value. Sorry, I check I check the sum of the current value, the current sum, and this new number, -2, and if it's positive, then I will save that to my current sum.
Okay.
But I still have 3 as my largest, right?
Okay.
And then I look at the next number. I guess I keep summing up numbers until I see the next negative number. So I see this, it's positive. So I add 4 to this number, to the current sum. And that is larger than the largest number, so I replace that with this. And then I skip ahead till I see the next negative number, which is 10, -10. And then so I look at the current sum, and I add that to the current sum, and I see that it's actually a negative number. So that means I should just discard the sum. And I go to the next one, and it's a positive number, so I just add that to the current sum and compare. Is it larger than the largest? No. So nothing happens. And I've stepped through the entire array and what happens is I see that the largest sum was 5, which confirms our initial solution. So I think I might have a better idea of what to do. So let's try this with a more complicated example. So I'm going to have multiple negative numbers together with multiple positive numbers. As well as alternating numbers. Maybe this isn't the...
make the 1 a 3 that's bigger than the -2. Absolute value.
Okay. So I'll start with this, the current sum. And also the largest sum. So I start here. It's a negative number. The current sum is negative, right? So I skip it, start it. The current sum is 0 plus -8. Which is smaller than, well, actually, which is negative, so I discard that as well. 0 plus the current sum. The current sum is 7. Largest is 7. So I keep summing up. If I see a positive number, I just sum it. And I'll update the largest as necessary. And then I see a negative number. So what happens is, well, I add that to the current sum. And I see that it's still a positive number, so I don't reset it to 0. Okay, this is, so as usual, I sum it, and it's larger than a large number, so it's 26. So, and I keep going, and I see another negative number. And even though I know that it's the end, I will still do this. And I don't have to update the largest number. So this is the largest contiguous sequence here is 26.
Mm-hmm.
And that is from here to here.
Yep.
And do I have to, so it works because so in cases where I see, the sum is interrupted by a negative number, and adding that negative number would make the sum negative, then I know that there's no point in continuing that sequence because it could always be, if I didn't include that part, it would be, the sequence would be greater than if I included it. So yeah, I that's the best I can explain it.
Okay. Yeah.
So
why don't we jump into coding?
Yeah. Okay. So so I'm given an array of, so I want to return an integer, the value of the largest contiguous sequence. And I'm given an array of numbers. So as I said, I would step through the array starting array. I need to keep track of the largest sum and also the current sum. And I have to step through the array. So for integer n in array of numbers, so I'm going to add that to the current sum. So current sum plus equals n. And if the current sum is then less than 1 or less than or equal to 0, so if the sum was like 0, then it wouldn't make a difference. So actually, you could attach that to another sequence, and it would still give you the same number.
Mm-hmm.
But in our case, we're just looking for the max value. We're not looking for the sequence, so
Right.
It doesn't matter. So, but anyway, I'm just gonna say if it's less than 0, then we want to reset it to 0. So current sum will be equal to 0, and then largest sum would be the larger of itself, or so if the current sum is larger than the largest sum, then we set it to the current sum. Otherwise, it's still itself. Current sum greater than the largest sum. Yep.
Mm-hmm. Mm-hmm.
And okay, I feel like maybe I'm missing something, but I'm gonna step through it anyway. So starting at -8. So let's say largest sum, current sum, so let's say -8, right? -8, current sum is now -8. If current sum is less than 0, which it is, then it's just 0 again. So maybe it should be 0. And the largest sum is, of course, still 0. We see another -8, so we do the same thing. We see 7 next. So so current sum is now 7 because current sum plus equals n. And if current sum is less than 0, it's not. So we skip this, and the largest sum is current sum. Now 7 plus 14 is 14, and the same thing happens. I'm going to simplify the next 2 steps because we're looking at positive numbers. Sorry. So 7, 14, 20, 25. So the current sum was 25, and the largest sum is, of course, set to 25. Now we have -2. And for if n is -2, the current sum, you add -2 to the current sum, giving you 23. Now it's positive, so nothing happens here. The largest sum doesn't change because current sum is not larger than largest sum. And we keep going. Let's see if I can move this to the right slightly. And then we see 3. 3, we add 3 to the current sum, which gives us 26. And yes, so largest sum is changed to 26 as well. We see -3 again. Subtract that from, add that to the current sum, which gives us 23. Largest sum doesn't change. And at the end, we, of course, want to return the largest sum. Yep, and I think that's it.
Yeah, okay. Would this still work if all you had was negative numbers?
So I need to,
No, I think, don't touch the code, just,
okay, so it wouldn't because it would return 0 as the largest sum.
Okay.
But,
so what's the condition for this algorithm to work?
So there has to be at least one positive number, one number. So at least one of the elements has to be greater or equal to 0.
Yep. Okay. Yeah. So that is the correct solution.
Okay. Great. So what's your feedback?
That's 35. It's around like 37 minutes.
Okay.
It's within time. It's pretty good. Yeah, so like when I did this problem too, I like struggled with the concepts.
Yeah.
A lot in the beginning. And for me, it was just kind of feeling. So you tried outside in, you tried middle out, right? But there will always be like kind of a case where you hit a pretty big negative number on your way, but there's something over it that might get you even bigger. So it's good that you thought of these these scenarios. Yeah, the one thing I struggle with a lot, but now thinking back, it's like, wow, why didn't this just click for me? It's like the fact that the relationship between when do you ditch your first number for a future one, and that was the positive one, and I think you got it. Took you some time, but yeah, I think you got it.
I guess it makes sense because if you want to, like, if you think it's worth including the next positive number, sometimes it makes more sense just to include that next positive number.
Yeah.
Yep.
I think you asked good questions for the beginning, and yeah, I don't have too much to say about it. I think everything went pretty smoothly.
Okay. Great. Thanks a lot, Sean.
Yeah, no problem. And that wraps it up for this session.
Yep. Thanks everyone for tuning in. See you next time.